Hello, welcome to the Botanical Night. This is a night on Iriomote Island. This is one of the southernmost island of whole Japan, very close to Taiwan, and this is a night from May 24 to May 25th. And this is a, male cycas. So plant looks like dead maybe, but cycads are similar to reptiles in the way that you can look on a reptile in a zoo and guess if it's alive at all or not. So cycads sometimes will lose completely their leaves, but they will regrow. They're extremely tough plants. So this is a male one, and you will have wonderful male cone on the top. Actually, not exactly on the top, actually feeling new leaves are growing here. So this is interesting, very interesting. We actually used to think that most of non-flowering seed plants, or prefer to call it gymnosperms, they have the fructifications to avoid term flower. The fructifications in dense lateral generative shoots. Again, cones. Lots of botanical terminology today. But there are gymnosperms which have no cones. Good example are gingos, and there are also some interesting exceptions which mainly explained by reduction. And among cycads, there are many genera. They all have male cones and all have female cones with exception of cycad. So Cycas revoluta in particular, has male cones but does not have female cones. Instead, female organs of Cycas revoluta are arranged exactly like leaves, so extremely similar to sporophylls of ferns. Sometimes ferns have strophophylls, green, and sporophylls for spores. So female Cycas has very interesting fern-like arrangement of female structures, but male structures are arranged in a very typical way. So how to explain it? It is not a reduction, because Cycas as a genus is a very basal genus to whole group of cycads, which consist of many more genera. So how to explain it? There is a term, complicated term, gamma heterotopy. That term was, used a lot by Russian paleobotanist Sergei Meyin, and he explained with this term some interesting problems of plant evolution. So what is gamma heterotopy anyway? This is a situation when one sex structure, not the sex itself, but morphological structure, starts to be taken by another sex. So, for example, it may be like flowers male and flowers female. Again, flowers male could be white, flowers female could be red, but then in evolutionary process, male flowers start to be red, exactly like females. So this is a bit of gamma heterotopy. And topy means like morphological changes, not just color. But anyway, you got an idea. So Meyin first explained on an example of fossil cardaids, and then use that interesting and unusual idea to explain the origin of flowering plants, because I will not go very deeply here, but at least one ancestor of flowering plants has male part very similar to stamens of flowering plants, but female is completely unsimilar. So Meyin, he actually hypothesized that female part of these ancestors, benetids, changed by gamma heterotopy, their position and how they look like, and start to be similar to flower of flowering plants. I think the better example of gamma heterotopy among plants are these ones. Imagine that is a kind of ancestral condition when we have non-cones for female and cones for male, and then just like a switcher program, and then female parts start to develop like a cone itself. In times when Meyin first discovered, actually developed ideas of gamma heterotopy, 1970s, it looks like a fantasy. But now, with all our knowledge about developmental programs, this is a very real thing. So it is not a surprise that many things in the plant world are just switched. So I think this is a good idea to discuss, maybe to test in some particular way, that in Cycas, genus of cycads, very basal one, female part during the evolution start to behave exactly like male, cone-like, and since that time all cycads start to be male and female with cones. In only one of them, Cycas, is still only male cones, and female cones are not present. So this is my night story about gamma heterotopy in Cycas. Thank you very much.